Dear students, let's start this very important concept, pairs of angles formed by our transversal line. So if you look at this diagram, you can see there are two parallel lines given here, line AB and line CD. And the arrow shows that these two lines are parallel to each other. And we know that the parallel lines never intersect even we extend these. There is another line given here which is intersecting this pair of parallel lines, and this line is called transversal line. So this line, if you see, this is a transversal line, and the reason is this line is intersecting this pair of parallel lines. Now you can see a few angles are formed here, and I have labeled these angles as A, B, C and D. In the same way, if you look at this part of the diagram, you can see four more angles here. So this transversal is going to form angle E, F, G and H with this line CD. Now according to the concept, according to the rule, if you measure this angle A and this angle E, you will find these two angles are same in size. So let's, if this is 30 degree, this is also going to be 30 degree, and this pair of angle is termed, or it is called as pair of corresponding angles, and these are always equal. So this means that angles intercepted by a transversal on the right hand side above the parallel lines, this will give you a pair of corresponding angles, and these are equal in size. In the same way, if you look at the left side of this transversal line, you will find this angle D, and its corresponding angle is going to be angle H. If you use a protractor, and you will find that this angle D and H are equal in size, and these two angles are formed on the left side of the transversal line above the parallel lines. So it means that if this is, let's say, if this is 120 degree, this is also going to be 120 degree. In the same way, this angle B, which is below the parallel line, is corresponding angle of this angle F, which is below the other parallel line. So if we suppose that if this is going to be 130 degree, this must be 130 degree also. So these will be same in size. In the same way, this angle C, which is on the left side below the parallel lines, this also forms a pair of corresponding angles. So angle C and angle G will also be equal in size. So you can see here we have formed four pairs of corresponding angles: angle A and angle E, angle D and angle H, angle B and angle F, angle C and angle G. So these are four pairs of corresponding angles. In the same way, if we talk about vertically opposite angles, we know that wherever we get a cross, then the angle opposite angles are equal in size. So this means angle A is going to be equal to this angle C. If let's say this is 60 degree, this is also going to be 60 degree. In the same way, we find this cross is here, so angle D is equal to angle B. So if this is 120 degree, this must be equal to 120 degree. So in this way, you can find two pairs of vertically opposite angles here: angle A and angle C, angle B and angle D. In the same way, if we look at this part of the diagram, angle E and G, this is a pair of vertically opposite angles, and angle H and angle F, this is a pair of vertically opposite angle, and these will be equal in size. Now one angle is left here, one type of angle, and this is called alternate angle. So if we look at this angle B, and if we look at the other angle subtended by this transversal on the other side, this is angle H. If you measure these two angles with the help of a protractor, you will find these will be equal in size. So these angles are said to be alternate angles. In the same way, angle C and angle E, which are subtended by this transversal line with the two parallel lines, this is another pair of alternate angle, and these will be same in size. So if this is, let's say, 45 degree, this must be 45 degree. So these are three different types of pairs of angles formed by a transversal on a parallel line.